I'll give you a really short demonstration of what it is like to be a professor, how painful it is.
If you have said it the very first time, so every week, every assignment at 1 p.m., I think you're...
No, that's minor. Only 1 or 2 people submitted at 5 p.m. and I'm sorry, but you will not be able to compete because I just received the submissions now. So let's start from here. So let's make this clear today. I'm not going to make fun of anyone in particular. Okay? It's just that I want you guys to realize. So, what did I say? Submit at 1 p.m. Of course, I got submissions at 5 p.m. I got even bored about saying 1 p.m., 1 p.m., and of course, somebody didn't listen. Then I say email subject, okay? This is pretty clear, email subject, yeah. And it looks like most of you actually listened. Most of you, oops, oh, look at that. Which actually is pretty helpful because, okay, the university is participating. Okay, then I say submit 3 notebooks. 1, 2, 3. Okay. Why do you think I say that? Because of course I like to automate things. So the emails with a certain header, with a certain subject, I can do stuff to them. So I know that there's going to be this particular file attached. You would think, okay, so these guys actually did the right thing. Let's continue. Very nice. Oh, okay. So then we get, so, oops, we have a targz. We have 2, okay. We have a zip. Now we have 4. What's going on? And then, of course, this doesn't comply at all, so it was in the, not something else was in the spam. Okay, enough for the emails. So I fixed this one by one, and I created our homework page. This was supposed to be closed, oh, that's okay, too. So, by the way, I don't know who the winners are. I don't know who the winners are, so there is no problem with this. Let's put this inside. Let's go problem by problem. Problem 1 and 2 were actually kind of boring. Maybe I should restart Mathematica altogether. That's a better idea.
Is there some way to do that without restarting Mathematica?
Yeah, there is a way. There is exit. It's pretty useful. So, okay. Almost all of my notebooks start with exit so that I don't have to restart Mathematica. You simply go back here and you do this, and this resets the kernel. So, problem number 1. This was a list of, there was a list of scrambled tones, and you guys had to fix this thing, the name of the tone with replacement rules. And I don't think it's worth spending too much time, but it's just a very straightforward solution was to go into strings, so try to separate all the characters and then traverse these characters from left to right via a replacement rule. And the moment I find M, so a character that is a number, I drop everything on the right, so I split the string L middle right. The moment M is a number, everything that is on the right is gone, and L and M constitutes my solution. Then the string join puts things together. It's nothing fancy, nothing advanced. And I'm sure that you guys have solved it in many different ways. Do you have questions or comments about this? Okay. Let's go to problem number 2. Problem number 2 was a little bit more involved. What's the story with problem number 2? You want to take these arrays and you clearly want to mix them, sort them together. At the same time, as you sort them, you don't want to lose the information of where these arrays are coming, where these numbers are coming from, because in the end, the structure of the output is the same as the structure of the input. So clearly, you cannot just lose that piece of information. You have to add it to the input and carry it through. So I think, oh yes, sorting and unsorting is an accurate definition. Over here, I go a little bit step by step. This is the function to generate a random number of lists with a random number of entries. So basically, this is creating a problem. And to test it, I put integers because I'm also interested in seeing what happens if there are ties, if the same entry appears in different lists. So that's why I created this with integers. And then, of course, if you replace it with real, it's more general. Okay, so this is, that's not very interesting. Let's try a different one. Okay, this seems more interesting. 4 arrays and they are all sorted. Okay, what am I doing here? I attach some information to the initial array. So the first list gets an extra 1, the second list gets a 2, the third list gets a 3, and so on. And by the way, this is by no means the optimal solution, it's just any solution. I'm showing something that's kind of intuitive. At this point, I can go ahead and sort my numbers, so I can perform this initial sort. This is fine. I'm not losing the information of where these numbers are coming from anymore. I am carrying this information because now I have this second entry. Here we go. So now the numbers are all sorted. Very good. And now I have the arithmetic bit. So this is the involved part. I have to decide who gets what. And so my strategy, and once again, I'm sure that there are many different strategies. Let's look at, for instance, at this example. My strategy is to, first of all, compute the baseline. So what is the minimum number of entries that each processor should take? By minimum, I mean, you know that 2 processors can differ at most by 1. So I'm asking, what is the minimum that any processor should take? So we take just the total number, we divide it by 5, the length by 5, and we round down, or you take just the integer division. That in this case it will be a 2, and there will be a remainder of 3. Okay, and in fact these 3 guys get 1 more. At that point, there is I have a mechanism with indices to keep track of where I am in this list, and if the processor is in the first 3 positions, then it gets the baseline plus 1. Baseline being 2, plus 1 because I know that there is a remainder of 3. If I am beyond this remainder, so if I am in these last 2 positions, there is no addition. That's how I do it. And this is here. This one here basically figures out whether I am in the left side, so if I get a +1 or not. And this one over here repeats this assignment for each entry of a list. Let's not get into the technicalities, I gave you the idea. Now, the important thing is that I keep expanding. I started from a list of entries, then I added one index, and now I'm adding more. Okay? In fact, I'm adding and scrambling. So now where I'm coming from is now the first entry, the value is the second entry, and the processor assignment is the third entry. Okay. So now I sort back. Why is this a sorting back? Because now I'm sorting, and this sorts according to the first entry, and the first entry, what is it? Is the index that tells me from which of these initial arrays I am coming from. Okay, if there are ties, sort operates on the second entry, so I'm actually reconstructing the identical structure of the initial input, and then we clear some stuff, and okay, and then we clear some stuff. Here we go. And then I put everything together into a function that does all the steps that I described above. So in input list and the final assignment. Do you have questions? Of course, there are many different ways of doing this. Yes?
I was under the impression that we couldn't use logic like if because we have to use
Functional style.
yeah.
What? So
It's only this third portion.
no while for table. Yes, map index, map thread, flatten, replacement rules. What's wrong with if?
Nothing, just.
So without if statements, it's not too difficult. My if statement is here, so it's just a matter of coding this as a constraint, right? So it's not that difficult.
I think you can even do this without any if or conditional. This block.
This one here?
Yeah. Just with division and sealing.
Oh, exactly. Yeah. Yeah, probably. I believe so. Yeah. Okie dokie. Other questions? How long did this take for you guys? Oh, really? Few hours, okay. Hours? What was the difficulty? For me, the conceptual thing is to carry on the information. So once you merge everything, the really, really crucial thing is to carry the knowledge of where you're coming from. Once you figure that one out, I think shouldn't take too long. But that might be the idea that lets you make it through. Okay, and now let's get to the part that we all are waiting for. Sequences. Okay, the first one was, well, before getting there, no, okay, let's look at the first one, the rule, the one only based on replacement rules. Of course, it was pretty easy to solve it, despite that thing that I didn't try last time. So how to reduce 12 to 1 and 2 only with replacement rules. It wasn't too difficult. Let's see how to do that. Replacement rules. Indenting is really a mess here, but let's see. So what do I do? my idea is we have seen this already, or something like close to this already. When we did the encoding, my idea is to start off, every time I find a number, I create a pair with the number, comma, 1. So basically I'm counting how many times I will count. I'm setting the stage to be able to count how many times I will encounter a character. So this is to begin with. Then over here there is the actual counting. Every time I find the same number in two different spots, positions in the list, I put them together, keep the number, and I add the occurrences. Okay, so step 1, I set the stage. Step 2, I count. Step 3, it's sorting. But now I have pairs, so I need my own sorting function. So how to do the sorting? We have to identify one entry, another entry, and we sort according to the second entry, so V and U. And here is the replacement rule to make sure that E1 is less than E2. Okay, at that point we have to do flatten. How do we do flatten? In this particular case, we can do flatten like this. Every time we catch a pair, we flatten it. So L, we can assume that has been flattened already. If not, it doesn't matter. We will catch it eventually. So we put it like that. A and B, now we remove the curly braces, so there is no pair. I do flat, and R, you can see that as a recursive call or whatever. You can assume that that has been done already. Doesn't matter. And finally, what if my number is what I caught is more than 10 as more than 9 instances? At that point, I check if I have found more than 9 occurrences of an entry. Then I can divide this entry. I can compute the quotient, its quotient by 10 and the remainder. And I better do this multiple times because maybe I have found 100 instances or 1,000 instances. So one such steps brings, let's say, 123 to 12.3. So I need multiple repetitions. Then the 12 will be taken down to 1, 2, 3. Questions about this? Yeah, absolutely. You can wait. So this is the sorting.
We are not sorting the appearance times. We just sort the value.
Oh, that's right. Yes, yes. You sort according to the second entry. Sure. Even though I thought about that. Even though here you're sorting fewer entries, right? Over here you're sorting at most 10 entries, and there you're sorting you don't know how many. It must be said that complexity considerations, this is so slow anyway, but in general always think about whether the order affects the complexity.
If you're arguing with that, you have to remember that you have to use an additional arbitrary length argument in the, you call it C underbar, because at this point the list is not sorted, so therefore this pattern will take n times as long as it would be if you did it after the sort. So in the end it will probably come out to be pretty much the same thing.
So yeah, basically, why do you use here the block code?
Oh, this is just to, if I don't do that, and I have used these variables somewhere else, in the replacement rules they are not protected. This is really annoying. So if I had assigned something to A, this A here, okay, this A here clearly is a pattern, no problem, but this A here would not be bound to this one. It would be a global A. So it would not work at all. Yeah?
Is it not kind of cheating to use function calls such as quoting?
Okay. What do you have instead?
Just using normal basic rules and guards.
Such as? Give me a guard. So guard something like this, fine.
So if it's gauge more than 10,
Yeah?
then you split them open without using
Okay, if it's more than 10, like here, fine. Then how do you break it down?
then you would say, or you need more symbols in your pattern.
Ah, okay. Okay, cool. Yeah?
You can also simply go ahead and take apart the n by successively subtracting 10. Then you have the modulo, and you can just. With the
Sure,
modulo
why not?
calculate
Yeah,
it.
yeah, yeah. Yeah, that's a good idea too. All right, how long did this take? 5 minutes? half an hour. All right. Okay, guys, now let's see how painful this really was for me. Submissions. So what I did, I collected all of your submissions for the fast challenge. Start off, this is the first one I got. Oh, it's gonna work for sure, yes. Fast equals short. Thank you.
Yeah, you put it in a different order.
I never said that we would compete for short before fast. So this is not gonna work. Okay, let's move on. I got lucky with a couple of them down here. Then we get to... Oh, wait. No, I didn't get lucky. What's this? It was supposed to be fast. Of course, it's not. Okay. Over here, we have something else. Yet, you guys are full of imagination, so no square brackets. Okay. Rule. Short. Well, okay, this is short because there was not a fast, so I said, okay, let me take short, I will use it. But this is seriously nasty. Look at this. This has become a pattern. Every subsequent evaluation will now clash with this. This was real nasty for me. Okay, let's continue. Fast, that's good. Oh, we have simple. Where did the simple come from? And then short. Okay, same story. There was not a fast. Then we have short. Just short. God knows who submitted this, right? Didn't I say, I don't know how many times I said name. I even made the example, I showed the example. Okay, followed by fast. Yeah, these are two different submissions, by the way. So, here is Paolo with a lot of patience going through one by one, trying to create an entry that would at least compete. And please, since I did this, check and see if it makes sense what I created, and also check whether you're here or not. So I compiled this list. Haha, now there is no underscore anymore. Okay. Any complaints? So it looks like I did a good job. And then there is the short. This is already a fixed list because I had the exact same problems for short as I had for fast. So this is the shorts. It's interesting. somebody said, yeah, we know this is nowhere near short, but that's the shortest we could find. So, all right, so this is what we have. Let's compete, or let's start. Before we can determine whether you guys are fast or short, we need to make sure that what you submitted does the job. I got 14 submissions at 1 p.m. And I'm sorry if you submitted after that. I mean, 5 p.m. clearly didn't work. Do you guys see your name? Do you think you should be here, but you're not? No, very good. So these are the guys that submitted. Oh, I have to evaluate. Yeah, probably there are problems, but that's okay. So let's use my submission as a reference. And what we're doing here is I am testing each one of you guys against mine. A different way would be to make sure that everybody gets the same output. First of all, this is impossible. You would be living in a dream world if that happened. And second of all, I want to print the name of the guy, of whoever doesn't comply, okay, whoever fails. So that then I can go back and see if we can easily fix the problem or not. So here we go. N equals 5, boom, all sorts of problems. Wait. Yeah.
Did you evaluate short?
Yeah, that's the problem. Good point. So, again. So if you're true, you are one of the lucky guys, but there are already a couple of that guys. So, Ippen, yeah, you are here, so we can look at yours. Yeah, I know. So, whoever defined pure functions, yeah, you guys encrypted your name and didn't let me access it, of course. I didn't expect pure functions, of course. 3 or 4 of you had pure functions. So let's take Ippen and the fourth from the end. So Ippen fixed. Oh no! Before going there, I went one step further. Where is it? I went one step further to plot the actual. Yes, I think this is it. Endangered, yes. So we take this one. I just have to put it there. And now we have to count the fourth from the hand. It's Lubish. Here you go. Yeah, and you are here too. I see you. So let's put this guy here. Endangered. Okay. By the way, 5, it doesn't mean that I am executing the program on the number 5. It means that I'm creating a sequence with 5 numbers. So with this, I can go to very, very long sequences. Let's see what happens. Oh, man. This is nasty. I mean, this is the output. The first row is the output from Ippen, and the second row is from Lubish. It doesn't look like we're going anywhere anytime soon.
Because I know what's going. Because we defined S in as is.
You defined S as in S?
Sn as S.
You defined Sn as S. Okay, how do we fix it?
Just add n after S.
So, here,
Yeah.
N,
Yeah.
that's it? This does it?
make a function out of the whole thing? So wondering.
Oh, no, that's too much of a fix. So if this works, we are happy. Oh, here.
They don't return. There are some functions we call them.
So we have one killed. What about Tammo? Any idea what's going on? Okay, we can take a look. This is the guy that is endangered. He's very close to be killed. If anyone can solve this quickly, Okay, Tamo says no. So we have the first two deads. Let me keep this. The original list, let me keep it. We remove 1 and 2. So we're down to 12. So these 12, everybody seems to be working fine. Wait a second. Let's try with the 500. Why? Because now, or even 50, 150, now I know what's going to happen. Now, for sure, there will be instances, well, numbers with more than 9 instances, occurrences. So let's see if everybody took care of that case. Boom! And there are few people close to that. So we can look at them. Farshad. And Kartik. Slava, right? I'm not going to try to pronounce that. Wrong. Okay, let's see what happens. Let's go to 50. Of course. 150. And sure enough, none of them actually solves the problem. So they kind of do the right thing. Too bad at the moment we passed 10, they all die.
Can you put yours there too?
Sorry?
Can you put yours there too, just to compare what it should be?
That was Paolo Short. I don't know why this is.
Is there any way to have it stop auto-indenting?
Auto-indenting?
When
You can
delete
switch it to
something,
raw
it just-
input.
To what?
Raw input, then you just have text.
Because sometimes it'll just move it back up, and sometimes it moves it down.
It was fast, the Paolo. Short. No, short, the Paolo, right? Fast, short. Oh, I see. Because no, I don't have a fast Di Paolo, that's why. So let me just add
Put someone who gave the same answer as you in there and everything will be easy.
that too. That's a good idea. So here we go. So you want the 14 to be broken down in 1, 4, 11, 1, 1, and so on. 16, 1, 6, and so on. So now the question is, what do we do? Do we fix these guys or we declare them dead?
They fall the same case. Just map integer digit and that's nothing again.
So you are thumb up. You are a nice guy.
It won't help them anyway.
Okay, so help me here. We have to go to Farshad, Kartik, one by one.
Because that fix is
Kartik,
slow.
that So we have to do
White, low, smallest.
then map something to everything, then flatten again, you can
Yeah, but
almost
this-
always
but
improve
this
upon
we
that
get it.
by getting rid
No.
of one of the flattenings or something like that.
How would we want that?
So this should work, right? Just mapping integer digits.
Now we need to flatten again.
Really?
Yeah, because
Because
integer
now we
digits
have-
returns a list of
Okay.
the integer digits.
So that was one. Who else was there? Farshad. Yeah. Who else was there? Slava, I remember. Here. And Wang too, yeah. Let's see, hopefully that does it. Yeah, this is it. Good. Just to make sure, let's go to even higher. Okay, so far so good. So now we can enter the competition. Participants are all the, what did I say? Submissions. $12. Okay, here I define my function to create problems. Once again, this is not the number on which I am testing. I am creating a list that long. And I test the speed simply on one iteration. Basically, I create a really, really long number and I see how fast you can process it. The number is so long that I don't need to do iterations or repeat or whatever. So just one go is enough. So let's see if everything works fine. We're going to have a list of participants, and this is a number of 10 digits, okay? And now we can go up to 4, maybe 3. I don't know if anyone is super slow. Okay, we can go to 4. And I think we have to kill somebody already because this is taking ages. So what's going to happen? Let's see. Probably Hafiz is going. Wang is also going for sure, right? Yeah. So there must be a clever way of discarding people by name, but for now I just kill them one by one. So Hafiz is gone and Wang is gone.
Evaluate the participants.
Thank you. And it's starting to take long, so maybe it wasn't a good idea to go to 6. Okay. And more people are dying. Daniel Schammel is gone and Farshad is also gone. Daniel is gone. Farshad. So we have 8. Maybe I can call them quarter finalists. So. Wait. Yeah. Again, maybe I was a little ambitious. Let me try something else. Yeah, let me try this. Okay. Oh, we have the finalists. We clearly have the two finalists.
Yeah, I think they don't differ that much.
No, they're almost identical.
Yeah, no, I mean the functions don't differ that much because we use the same math.
I know. As I said, finalists.
Is there any difference?
And yes, there is some tiny difference. I don't know if it's just syntactical or not. But I honestly have not seen who will win. Finalists, thank you. Otherwise, this would finalists. So 1 second, let me see here. 333. Okay, all of you guys died at the same time. I wonder if you are using the same.
What about your solution?
What?
Your solution?
No, I didn't know. I mean, I knew about tally, but I didn't remember about tally. So I would be out at the first round. You killed me, guys, here.
I think number generation takes a bit long.
Yeah, that too, that's true. Well, this is a very long number, by the way. Maybe I didn't need to go to 9, but... Oh, that's a good question. Yeah, I think so. Yeah, I think so. I think so. So who are the finalists, by the way? That corner right there. Let's see. Oh, it's happening. Frozen. Yeah. Mm. There is a clear winner. I can see it. Did it crash on 7 or 8?
On 9.
9. Okay, so we can go to... Yeah, it's the same. Oh, look at that. Now it's reversed.
Yeah, but that mathematical unit precise timing function.
Okay, just since they are clearly the winners, it's a tie, okay, guys? Let's look at, yeah. Congratulations, and let's give honor to the winners. It's pretty much the exact same thing, just using slightly different notation and then the comma 2, which I don't think you need. Because if you like, this is a function application and like that is a mapping. Okay, so yes, you do. If you do like that, if you go with a function call, yes, you do need this. Means that you reverse at the second level. Otherwise, you can just map.
Why can they call integer digits nothing like that?
Say it again?
Why can they call integer digits like that? Doesn't it? Because we map integer digits too.
We just do it at the whole list, and it takes just the functionality of integer digits. It just makes every integer and splits it up in cases.
Okay, so that's done one character less or short.
Yeah, same for me. I didn't know that. Yeah, I could have used that too. Do you guys have other questions about this? Do you want to discuss your own solutions? So should we look at the final challenge, shortest? Well, first of all, we have to test the shortest as well. And that should be here. This is the test for the short. Let's see. Okay, now we try the short functions. Did I evaluate everything? I think I did. Yeah. Of course not. So submissions is missing. And we have a bunch of people that didn't comply. In fact, if I go to 150, most of the people didn't comply. I think we can kill all of them. And so we have only the first 6. Wait, where am I? Oh, maybe I'm not in the initial list. So, well, what this means is that we have to look at the programs of the first 6 entries. So, first 6 submissions. So, we have the same 2 guys. Then we have a short, short, short. 1, 2, 3, 4, 5, and 6. Is mine the next? No. So let me take mine.
Union becomes a single digit.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Here.
I think we should argue that we want to see the raw input, not the print.
Okay.
How do you create that union thing?
This one.
So that's like 10 characters.
So, but now, if I do this, I actually win. I didn't know that. Okay, let's. Do you guys have a count of your submissions? Yeah, I think yours is 46. Mine is 46. And I think people in the middle are more than 46.
Oh, can we put on the mapping?
Can we do?
Just like you just did.
Okay. So this is 46. So I would go down to 45 if I remove that. So we are even again. Okay. I want to show you what I came up with because this is really involved. So first of all, I didn't use tally. How many of you know what tally does? Yeah, not too many. I totally forgot about tally. That's a good function.
Your trick is in tallies, you can, what you can do with tally.
Yeah,
It's the same as sort tally, and if you go to the tally documentation, what you're doing as very involved trick is just written there.
Say it again.
Your very involved trick is in the documentation for tally.
Really?
Yes.
But they wrote union in full form, not.
Losers. So what tally does? What tally does, it gives you the list of entries with the multiplicities. So 1, 1, 1, here you go, 1, there is 3 times. There are several problems with tallies though. For instance, if you put a 3 in the front, the 3 is the first entry, so you have to sort the tally. Also, with respect to what we wanted, there are 3 1s, there are 4 2s, and so on. And over here instead, well, 3, 3, it's not a good example. Over here instead it says there are 4 3s, so it's the other way around. So you have to reverse and sort these guys. And I'm like, nah, I can do better. No, actually I'm lying. I just didn't think of tally at all. I used the count. Now count, you pass where, or the list in which you want to count. And then you have to pass what you want to count. So for instance, number 3. And with this, it's really nice to create the number and how many occurrences of a certain number. So you don't have to sort anymore. The problem is what to put here on the right hand side. So if you put, for instance, you could create a map and apply it to all the entries, for instance 0, 1, 2, something like this. And okay, this will be nice. You could go with a range from 0 to 9. And so you wouldn't have even to sort. So you have the sort works and the reverse works automatically. But maybe there is a 0, so you would have to filter. Is that what you...
No, actually you don't need to map. You can apply a count on a set, on a list.
Really? That doesn't make sense. Okay. I hope it, truly hope it's not true, yes.
I'm sorry.
That's okay. So the problem is, if I put all the integers between 0 and 9, then I have to filter, because maybe I get some zeros, like too many maps. Vice versa, what if you take the union? So if over here you put union of the list that you want to so what does union do? It's a set, and so all the duplicates are eliminated, and also it's a sorted set. So I automatically get only the entries that I care for, in which case 1, 2, and 3, and in the right order. And so with count and the union, I can surpass, I can avoid the reverse, and I can avoid the sorting. The extra trick is that union can be written like this, but only if you use it as a binary operator. So you can use it like that only if you say A union B. You cannot simply say union of a list. And then I said, okay, that's fine. I'm going to union with the empty list.
Actually,
What?
I did like that, but I used the wrong version.
Oh. Oops. Unfortunately, that didn't work because of the stupid precedences. So I had to add the parentheses. But in the end, it was 1 character shorter than using union. So, congratulations to you guys. And also notice the use of the infix function call, count with 2 arguments. It's count, it's put in the middle, tilde, tilde. That saves me 1 character, because the function call would be f square brackets, and since it has 2 arguments, there is a comma. And so instead here I have a function and just 2 characters, so I save 1. Questions? No? Yes?
Since you didn't use a pure function, did you consider the square bracket x underbar square bracket?
No, I didn't count those.
Oh, so you cheated. Okay.
That's true. So I started counting after the definition. That's right.
And since the definition is a column equals, you lose another character there too.
No, it's okay. I decide the rules, so so this is fine.
The 1 character shorter.
And by the way, so this raises a point. I was not able to find any difference between. Okay. Here you have a pure function assigned with the equal. Somebody has a pure function assigned with the delayed assignment. And I could not find any difference. I tried, If you guys come up with any difference, please let me know. I'm curious. Otherwise, I will have to write to the Mathematica forum. Anyway, this is it. Congratulations to you guys and to myself.